Greetings, welcome back to ECD Laboratory, second semester, Unit 1. In this Unit 1, this is about session number 3. Session number 3, I'm going to explain about what are all the active components. See, active component in two sessions, session 1 and session 2, I'd explained about passive component. In this session, I'm going to discuss about active component. So, active component is requires external power supply to operate, and it amplifies the input signals. It means it increases the input signal. Whatever you give in signal, that will be increased in the output side. That is called active component. The session number 3 has a two part. One is about theory part, another is a practical part. This is about theory part. In this in this session, the three active devices called as a diode, Zener diode, and a BJT transistor. These three I'm going to explain. The main agenda, main aim of this video is to identify of the devices and identify the terminals of the devices and applications and the role and different types. These are all the four agendas, main points I'm going to explain. See, first is about diode. What is meant by the diode? Diode is an active component. It has the two terminal. It's a passes the current in one direction only. See, that means called unidirectional device. The diode is called as a unidirectional device. Means it flows the current from the anode to cathode in one direction, and it blocks the current flow from the cathode to anode. See, this will never going to happen. That's why it's called as a unidirectional devices. It's our two terminal. Diode is made up of a two semiconductor. The semiconductor name called as a p-type semiconductor, n-type semiconductor joined together, and it becomes a diode. See that sometimes they also called as a p-n junction diode also. Why they call p-n junction? There is a p-type semiconductor and n-type semiconductor come close contact, and they form, there is a junction across this point. That's why they called as a p-n junction diode, or they call that is a diode. And there is a two terminal. There is a one anode terminal, another is a cathode terminal. Anode terminal is connected to p side and cathode terminal is connected to n side. The working of diode and all these things, it will going to explain in a coming videos. It will be available in session number 5 and 6. I'm going to detail explain about diode working, how diodes will be formed and all these things. But in this presentation, it is only limited to identification of diode, identification of terminals and applications, and different types of the diode that I'm going to explain. See, it's just an introduction. Diode is a two-layer PN junction diode. There is a two terminal, and this is a symbol. Diode symbol looks like this. And how this will be work? See, this is just layman concept. That's a water analogy. We can explain how this will be. Water analogy means you assume that there is a dam. In this dam there is a full of water, and there is a gate. So this is a gate, you can say. This gate will be open only when there is a anode have a positive potential and cathode has a negative potential. If you apply a positive potential across anode and a negative potential across cathode, the gate will be applied and water will be flows. So this is called as a, in this direction the current flows from the anode to cathode. This is a forward bias. The name called as a forward bias. And reverse bias means if they apply the reverse voltage, the positive voltage across cathode terminal and negative voltage applied across this anode terminal, never going to open this door. This door will never going to open. This will like a pulling, it will strengthening the door by extra spring, and the water will never flows. Means here instead of water we can assume this current. See, in forward direction current will be flows, in reverse direction there is no current flow. This is that's why the diode is called as an unidirection. The current flows only one direction, that is in forward bias. The no current flows in the reverse direction. So that's why they used in a unidirectional current controlling element, current direction control element. They can be used this diode. There are different types of the diodes available in market. The few classification and the few number. This is a technical specification number 1N34A, 1N67A. These are all the numbers we can see, and they're made up of germanium. The semiconductor has a three type: germanium, silicon, and gallium arsenide. If the diode is made up of germanium, we can say it's a germanium diode. These are all the three diodes available in germanium diode, and the breakdown voltage is very less. It's a 0.3 voltage. And silicon diode, it's a 0.7 voltage. All you will came to know what is mean by breakdown voltage, how we have to calculate breakdown voltage in a coming video. But in this video you should know how diode looks, and what are different types, and identification of the terminal. See, there are some rectifier element also is there. Main concept diode is used for as an rectifier. Why? Because means it's convert the alternating component to direct component, because it works only in unidirectional. And there is some peak inverse voltage. This is also one important specification parameter, and maximum current and maximum reverse current and peak surge current and maximum voltage drop. So these are all the important specification while selecting the diode. One has to see, and as per the application he has to decide. And how diode will be symbols written. See, this is a symbol they will be written. See, this is a, if you consider a P type and N type, the P type will be triangle, N type is a bar. So this bar says N. See, the arrow mark indication the current, the flow of current always from the anode to cathode. That's why the arrow mark indication, and the bar indicates the N. It's like a gate. See, this gate will be open when it is a positive, and when it is a negative, the gate will be closed. This is a understanding of the symbol. Somewhere some textbooks have different symbol also. It's a filled triangle, and the triangle with a bar, and a triangle, and there is a line also. So these are all the way they can represented a symbol, a different symbol. And different types of diode. There are a lot of types of diode, depends upon the application, depends upon the made of the material. One is called as an PN junction diode, and Zener diode, avalanche diode, photodiode, light emitting diode, laser diode, tunnel diode, Schottky diode, varactor diode. There are plenty of varieties of the types of the diode. See, in this picture you can see rectifier diode, the one we are going to discuss, simple diode. This is a diode picture, and Zener diode will going to have a discussion also. This is about Zener diode and Schottky diode. These are all will not go into discussion, but in unit number 3 and unit number 2 I am going to explain about LED, photodiode, and these two diodes we will going to see it. See, this is about different types of the diode, and how diode will be looks. See, these are all the different varieties of the diode. See, here there is like a orange color, and there is a black color. So this is about Zener diode, and these are all called rectifier diode. And you see the size is keep on increases. What is indication means the smaller the size means smaller the voltage capacity, larger the size means it handles the larger voltage. And this is called as a surface mount, this is also through wall package. This diode terminal can be represented with the help of symbol printed on this body. You can see this is a anode and this is a cathode. Here the symbol you can see, and this having heat sink also. Why they have heat sink means it's handling more power. That's why they are manufactured like this. And these are all the diodes. You can have a one white colored band across one terminal. This indicates that's a cathode. This is about cathode. And the other terminal is a anode. See how we will going to identify the terminals of the diode means the one with have a color band, white color band or silver color band, that is a cathode terminal. The other point will be anode point. See this way. The other way is to have a symbol. They have a symbol, with the help of symbol they can identify the anode and cathode. These are all the different package of the diode which is available in market. Can be categorized to through two things. One is a through wall and a surface mount devices. This is a diode package, anode and cathode. Anode is a positive and a negative. The one which have a color band at the one terminal is called as a cathode. The another which is a anode terminal. And this is a TO. TO means it's a transistor package, that is called TO. It's a 220. This is having a symbol here. And the surface mount diode, there is a one kind of diode also. It's a anode, and this is about a cathode. And there is a heat sink. This for power diode, we can say it's a large power diode. There are some diode with ICs also available. So these are all the different types of diode will available in market. We can use it in our experiment also, or you can use it in your building application. See, while considering the package, the size of the diode and their dimensions, all these things is important. Why? Because means you need to place this diode on the PCB. It takes some space. See, you need to calculate that space also. That's why they are given all this dimension also. The terminal length A, both the terminal have a uniformly length, and the B, the body length. All the dimensions in a millimeter, and how much area it will be take. This is about top view and front view. This is about one is a surface mount diode. This is a our dimension. You can see this is the dimension. See, all these things is necessary while doing PCB manufacturing. This is a package size. All these things is important. And how to identify the diode terminal, I already told there are two types of diode terminal. Some diode terminals have a band, here you can see that is a cathode, and some diode, like especially BY127, this diode has a one edge is having a C type. So there is a curve at the one edge. This curve indicate this is a cathode point. The other one flat edge is called as an anode point. This is the one way to identify the diode, that is especially BY127. The OA80, it's a Zener diode. The Zener diode has a red point. The red indication is a cathode, and this is about anode. Okay, so there's a PN junction diode and a Schottky diode and the Zener diode, different types of the diode, how it will be look, and different symbol also. PN junction diode is the same, and Schottky diode there is a S, it's written S symbol, and Zener diode it's a Z. There is a Z LED light emitting, arrow mark indicate light emitting. Photodiode, light falling onto the diode, that is a varactor diode. Is having capacitor across the N side, so this is about varactor diode. And pin diode, this is about the symbol of pin diode. So these are all the different varieties of the diode is available, and we can use it in our application. And how we what are all the modes of operation, it's there. But you need only PN junction diode and Zener diode and photodiode. So these three diodes we will going to use. And there is a electric characteristic. If you open a diode data sheet, it looks like this. It's this is the important sheet. It gives the specification on what parameter we can use. This will going to have a detailed explanation in the coming video, but you should know each diode manufactured by some company. That company provides information in a data sheet. If you open a data sheet, you will go to see all this information. These are all the information will needed for circuit design, and this is very important. Based upon this only we will going to design a circuit. And the application where we are going to use this diodes. Diode is called as a rectifier element. So rectifier element is a diode. It converts the AC to DC. This is the basic component used in rectifier circuit, and you can use this diode as a switches, clipper circuit, clamper circuit, and reverse current protection circuit also, and logic gates, voltage multiplier, voltage regulator, freewheeling diode. Freewheeling diodes are even flyback diodes. So over voltage protection also diode can be used as a switch in digital logics, are used in computers. Diodes are used in demodulation. There are plenty of application. Majorly we are concentrated about rectifier, and we are concentrated about the and clipper and clamper. And with the help of Zener diode we can able to design the voltage regulator also. These are all the four applications we do in our laboratory. And the second one we call that is a Zener diode. This is a special type of diode. Means it's like a same as on a PN junction, but this P material and N material is highly doped. See, at this point you will not be able to know what is meant by highly doped. You will going to clear this concept at the end of the 5th session. I will going to explain, I will assure what is meant by doping and all these things. But at this point you should know the Zener diode is made up of highly doped PN junction. If you the same PN junction with highly doped, then it becomes a Zener diode. Zener diode which works in a reverse bias. So you need to use this in a reverse bias. But in PN junction diode, forward bias current flows. In reverse bias there is no current flow. But if you consider water analogy, it's a layman concept. If you apply a positive voltage, that is a forward bias, positive voltage across anode and negative voltage across cathode, the gate will open and current will flow with a small voltage. It's of 0.7 voltage, the gate will be open. If it is a reverse bias voltage, there is a specification says that the diode have a 12 volt cut-in voltage. Means 12 volt cut-in voltage means the gate will open only when you apply more than 12 voltage. See, if it is if the reverse voltage is less than 12 voltage, the gate will be closed. Whenever you apply reverse voltage equal to or greater than 12 volt, then the gate will open and water will flow. That's why the Zener diode current flows in both direction, forward bias as well as reverse bias. But in reverse bias it will open only when there is a breakdown voltage, that is called as a Zener breakdown voltage. When the voltage reaches to the Zener breakdown voltage, reverse voltage, then only current will be flow. That's why we need to use this Zener diode in a reverse bias direction. I should be know. And PA junction is always used in a forward bias junction. reverse bias we cannot use in a reverse bias condition. So this is about Zener diode, and there are some plenty of Zener diodes available in market. The main category, the Zener diode, will be classified based upon the breakdown voltage. Whatever we said here, no, 12 volt, the 12 volt gate open voltage, that is cut-in voltage, or you can say breakdown voltage. Based upon the breakdown voltage, Zener voltage can be categorized. It will be available from 2.4 into 100 volt. That is the variety, and there is a each have a number, specification number. That is a power handling capability 500 milliwatt, 1 watt and 5 watt. These are all the different power handling capability, and it's a surface mount. This is about a through wall, and this is about a surface mount devices available in market. And what is the role of diode? Why we need Zener diode? Zener diode, the main concept, Zener diode is a heavily doped semiconductor device that is designed to operate in reverse direction. So this is used in only reverse direction. In the sense, the voltage across the terminal of Zener diode is reverse, and its potential reaches to the Zener voltage, that is called knee voltage. The junction breakdowns and current flows through this reverse direction, and this is known as Zener effect. So this concept is called as an Zener effect, and it maintains that voltage. See, whenever there is a gate open, it reaches to the 12 volt. Gate will be open. The Zener breakdown has happened. See, current flows us, but voltage across this diode is always maintained 12 volt. See, that's why it's regulating. It stables the voltage. That's why it's used as a voltage regulator, voltage stabilizer. If you need a constant voltage, we are going to use the Zener voltage. Irrespective of changes in the input voltage or irrespective of changes in the load, it provides a constant voltage source. That's why it's called as a voltage regulator. And most of the power supply design, Zener voltage is used. Zener to be used in a simple voltage regulator, as it can act as a reverse current to flow at a voltage limited by a diode breakdown, and other application of Zener diode as a DC voltage regulator and a noise suppressor. This is also going to suppress the noise. That's why these are all the roles they used in a application. And this is the symbol. It's like a normal diode, but it's like a Z. You have to represent like a Z curve, and this the Z curve indication is a bar. Here there is a colored tape or there is a dot line. This indicates a cathode. This the bent line used in Zener symbol can be through as a open letter Z. See, it looks like a Z. This is about symbol, and there are different types: nominal voltage, power dissipation, forward driving current, forward voltage, package type, maximum reverse current. Based upon this, the Zener diode will be categorized, and you can see the package here. There is a black color tape. This is about cathode, and this is anode. This is a 1N4740. This is a Zener diode and Zener diode package. These are all the different packages available. This is a through wall package, and this is about surface mount package. Dual surface mount package is also available. And Zener diode specification. While selecting the Zener diode, one should has to focus on this parameter, that is Zener breakdown voltage, maximum current and current minimum, and power rating, temperature stability, voltage tolerance, and Zener resistance. These are all the important parameter one has to calculate it in the circuit, and the respect to Zener diode has to used in application. Otherwise the circuit will behave not as expected by the user. So these are all the applications. We can use this as a voltage regulator. We say Zener diode is used as a voltage regulator, and also used as a voltage shifter and waveform modifier and limiter and split supply from the single transformer winding. You can design the different power supplies. If you have a 5 volt and we can make it as a 2.5, we can make two power supply, that is called split power supply, and over voltage production, and increasing the wattage rating of the Zener clipper to generate the square wave, and standard reference voltage regulator. These are all the application used in Zener diode. Then coming to BJT, that is a called bipolar junction transistor. It is made up of 3-layer semiconductor, that is a you can say PNP or NPN, will see it, and 3 terminal. One is called base terminal, emitter terminal, and collector terminal. And see, this is the device introduced in 1948. This is 3%. You can see this is the transistor they have invented in a Bell laboratory. There are 3 scientists working in a Bell laboratory, American Bell laboratory. In that they come up with a concept called as a transistor. The innovation of this transistor changed the world. from 1948, before the 1948 they are using the vacuum tube. The vacuum tube is a larger sizes. While designing a computer with the help of the vacuum tube, it's a size of around one room, one big building. But after innovation of this transistor, the size is reduced. Nowadays we see this is a smartphone. The smartphone is a very powerful computer, and it's a very thin size. How this happened? Because of this innovation. So this is the breakthrough innovation in 1948 done by these three people, greatest scientists, and they got the Nobel Prize also in 1956. The friend William Schottky is the person, William Schottky, and Rare is John Burdeen, this is George Burdeen, and Wright Walter Bartin. These are all the three scientists. They come up with a concept called transistor in a Bell laboratory in 1948, and for this concept, for this innovation, they got the Nobel Prize in 1956. So this is a three important person. With the help of this, they have changed the world. And see, this is the device made up of three semiconductor material. They can use either NPN or PNPN, and there is a three terminal base emitter and collector. How this will be work? So this is a NPN transistor, water analogy. See, there is a detailed description. We'll see it in a coming chapter. See how this NPN transistor will work based upon the water analogy. Just simple concept. There is a dam. It's a full of water, and there is a gate. See, this gate will be open when you give a small triggering voltage across the base. Whenever you give a small triggering voltage, this will going to push. See, you can see here, this is a supporting, and it will going to push. Whenever you push this, this will be gate open, and the larger water will be flows. See, in the sense, the dam water will be open with only few tap water. See, the smaller control of water, the small water controls the larger dam gate. See, this way. See, means whenever you apply small water across the base, this will going to push. This lever will going to push, and the main gate will open, and the larger current flows. So this is the NPN concept. In the sense, there is a voltage across collector or current waiting across the collector. This current will start flows from the collector to emitter. When it will going to start flows, whenever you apply a current across the base. If you apply a small current across the base, the current flows from the collector to emitter. This is the working of NPN transistor. See, like this, at the beginning it is off situation. Whenever you apply a voltage across the base, it becomes on. See, this is a symbol. You can see here. So this is the symbol. I have a three terminal base, collector, and emitter. Arrow mark indicates it's a NPN. This is NPN transistor, and this is a three scientists, they are innovated this concept. And there is a one more concept, PNPN. What will be PNPN? It's a reverse of the NPN. Initially there is a water flows from the collector to emitter. There is a flow of water. By applying small water, this, if you apply small water, what will happen? So this lever will going to push. See here, you can see this lever will going to push it, and it will close this wall, and it avoids the flow of current. See, initially the current will be flows. Initially the water flows because of the gate is open. Whenever you apply a small voltage across the base, the gate will close. So this is the concept, simple concept. If you go with this concept, it will be very easy. But if you go in depth about PNPN and how this majority carrier and minority carrier flows and all these things, it was very difficult. But with the help of this water energy, you can map those concepts, and it will be easily understand. See, this is a concept, PNPN transistor symbol. Initially it is on, the current is flows from the collector to emitter point. Whenever apply means initially it's on. Whenever apply a base voltage, and this will go into off, make it off, means it will avoid the flow of current. This is a water analogy of PNPN transistor. There are different transistors available in market. There are famously most of the laboratory, they use this kind of transistor NPN. There is a 2N3904 and PNPN 2N3906. These are all the transistor. Power transistor TIP 120. So this is a specification. 3904 is a NPN, 3906 is a PNPN, and maximum current switching, it's a 200 milliamp current gain, it's about 100. And there is a one more type of transistor is called BC type transistor. This BC have a NPN concept as well as PNPN. Both the types is available, and the package how it will be looks. This is a different number, and this is the way it will going to see. This is about the different types of the transistor available in market. And what is the main role of this transistor used as a switch as well as amplifier. The main concept, it can be used as a switch, like you can turn on or turn off, you can make the current flows or you can avoid the current flow, that is like a switch. And the transistor will amplifies the input signal, means the transistor needs a external power supply. With that external power supply, that is called biasing. With that biasing, it increases the input signal, and that's why they call it that is an active component. Transistor is a current control device, hence it is can be controlled by the applying the base current. Whenever you apply the base current, the transistor operation will be controlled. It can be used to amplify the weak signal, that is amplifier. It can also function as a switch. You can use this as a switch by alternating operation between the saturation and cutoff region. This point you will not be able to understand what is saturation and cutoff. We're going to address this in a coming presentation. Transistor is amplifier, taking the small signal and making them into large. It can also function as a switch because the small power can control the larger power. This is the role of the transistor, and this is a symbol. You should remember this. There is a two type NPN. This is the NPN transistor and PNPN transistor. This way they will write line, base, and there is a arrow mark. This arrow mark indicate NPN. This is the emitter. Always put the arrow mark across the emitter. The opposite of this emitter is a collector point, and the center one is a base. So this is a base, and this is a collector, and this is a emitter. Arrow mark towards the line, it says about P. It's a PNPN transistor. These are all the two symbols we used in our circuit representation. And there are different types transistor: small signal transistor, small switching transistor, high frequency, power, and Darlington pair, and photo transistor. We're going to see it in a coming presentation. And these are all the different packages available in market. You can see different transistor. Each transistor has a 3-terminal emitter, base, collector. You can see there is a transistor have a heat sink because it's a larger power handling capability, and this one have a larger power handling capability. You can say it's a more power handling capability. See, if you how can identify the terminology, means if this is having a flat surface, you hold this transistor flat surface towards your face, and the first one is says emitter, base, and collector. This is for NPN, and if it is a PNPN also, it's emitter, base, and collector. This is the way you can identify the base terminals of the transistor. You hold the flat surface towards your face, and the from left to right, it's emitter, base, collector. And these are all the different transistor and their name also: TO92, TO126, like this, the TO3, TO66. These are all the different transistor, and the size of the transistor is increasing because it's a low power handling capability is having high power handling capability. Depends upon the application. One has to go select the right one, otherwise it will going to damage the transistor. And see, this is another type of transistor. It's a cylindrical shape, and there is a notch here. You hold that notch. From the notch, it's a emitter, base, and collector. It's a clockwise direction: emitter, base, and collector. So this is the terminology. And the different packages available. Transistor package, it's a TO3. This is a this one transistor. This transistor package like this here. And these are all the remaining transistor. You can see this is a package is very important while placing the component on the PCB. With respect to the terminology, you can say here BCE, that means base, collector, and emitter. It's a terminology connecting that is a transistor terminals. BCE, that's a base, collector, and emitter. Like this, it's there, and emitter, base, there is a one more collector is a case. So this is a connecting point, and you can say it's a notch. From notch, it's a emitter, base, and collector. See, this is emitter, base, and collector. You should hold top of this kind of this one. From the notch, you have to use this like a clockwise emitter, base, and collector. So this way you can identify the terminology of the transistor. And there is plenty of application. The main application is to used as a switching and used as a amplifier, and you can use this as a controlling circuit. That's why it's based on switch only. The transistor used in digital and analog circuit switch, used in amplifier, cellular phone, would be the one of the most widely used application and used in power regulator and control, used in modern IC. All the ICs build up with a transistor only. If you open a IC, inside there is a plenty of transistor, and switching and digital switches, amplification, converters, and automotive switching, electronic switches, eye driven capability, detection circuit, high frequency operation, demodulator, modulator, clipper, oscillator, television, mobile phone, computer, radio transmission, and audio amplifier. Transistor has a huge application. ವಿತೌಟ್ ದ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ವಿ ಕೆನಾಟ್ ಇಮ್ಯಾಜಿನ್ ದ ಕಂಪ್ಯೂಟರ್. ಇವತ್ತು ಕಂಪ್ಯೂಟರ್ನ ಇಮ್ಯಾಜ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತಂದಾಗ ಕಂಪ್ಯೂಟರ್ ಒಳಗಡೆ ಇರೋದು ಚಿಪ್ ಒಳಗಡೆ ಏನು ಬರುತ್ತೆ ಅಂದರೆ ಇಟ್ಸ್ ಅ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಓನ್ಲಿ. ದಟ್ಸ್ ಅ ಪ್ಲೆಂಟಿ ಆಫ್ ಅಪ್ಲಿಕೇಶನ್. ಥ್ಯಾಂಕ್ ಯು.